When we first started this chapter, I said that we were effectively going to be doing the same three problems over and over again throughout. We would be evaluating trigonometric functions, verifying trigonometric identities, and solving trigonometric equations. And we're going to continue to do that, but now we're going to be looking at a couple of more formulas. So what I've listed out here are the sum and difference formulas, and you can see them written out. So you may want to pause the video right now and jot these down. A couple of things that I want to highlight is that when we are taking the cosine of a plus b, just remember that we are going with the opposite signs as what's written here. So if it's cosine a plus b, the formulas has you subtracting the products of cosine a, cosine b, and sine a, sine b. And the opposite is going to be true for cosine a minus b. The main thing to remember here is that we are not distributing a trigonometric function. So you would not ever say something like sine of a plus b is equal to sine of a plus sine of b. A function is not something that you can distribute. It's not a variable. Okay, so if you have the sum and difference formulas written down, let's talk about what on earth you would use these for. Well, there are a couple of different utilities for the sum and difference formulas. Suppose, for example, I asked you to find the sine or the cosine of 75 degrees. Well, 75 degrees is not an angle that we're accustomed to working with on the unit circle, but we do know that 75 degrees is the sum of two angles that we are familiar with, 30 and 45 degrees. That is to say, we can rewrite cosine of 75 degrees as being the cosine of 30 degrees plus 45 degrees. And if we apply the sum formula for cosine, we can rewrite this as cosine of 30 times the cosine of 45 minus the sine of 30 times the sine of 45. So the sum formula for cosine allows us to evaluate the cosine of 75 degrees when previously all we really could do was enter it into a calculator. So let's evaluate this here. Cosine of 30 is root 3 over 2. Cosine of 45 is root 2 over 2. Sine of 30 degrees is 1/2. Sine of 45 degrees is root 2 over 2. So we can just simplify this as root 6 over 4 minus root 2 over 4. And this can be rewritten as a single fraction as such. Okay? Well, what about something like this now? The tangent of negative 13 pi over 12. Now, trying to come up with two angles in the unit circle that add up to negative 13 pi over 12 can be a little tricky. So oftentimes what I recommend here is actually to convert this into degrees. So let's do that. Let's take negative 13 pi over 12 and let's convert it into degrees. So we're going to multiply this by 180 over pi. So we're going to divide out those pi's. 12 goes into 180. What do we have here? 15 times. And that would give me negative 195 degrees. So now that we have this written as degrees, this might be a little bit easier for us to come up with two angles that we know in the unit circle we can find values for that add up to negative 195. So we could say that tangent of negative 195 is equal to the tangent of negative 135, for example, plus negative 60 degrees. Now, if you wanted to say negative 135 minus 60 degrees, that's fine as well. But let's evaluate this. So now we're going to use the tangent formula, which we have right over here. Where is it? Tangent of a plus b. Okay, so you haven't written that down, go ahead and do so. But now let's find this. So we've got the tangent of negative 135 plus the tangent of negative 60. All of this over 1 minus the tangent of negative 135 times the tangent of negative 60. Okay, so let's evaluate this here. So tangent of negative 135, well, that's going to give us 1. The tangent of negative 60, well, our y value is greater, so we're going to say negative root 3. So plus negative root 3 is minus root 3. And in the denominator, we have already evaluated these. Tangent of negative 135 is 1. Tangent of negative 60 is negative root 3. So if I'm subtracting a negative root 3, this is equivalent to just adding positive root 3. And we're going to rationalize this. We don't want to leave that radical in the denominator. So I'm going to go 1 minus root 3, 1 minus root 3. And when we go ahead and rationalize that, we've got, what is that? 1 minus 2 root 3 plus 3 over 1 minus 3. So that's 4 minus 2 root 3 over negative 2. And this simplifies to negative 2 plus root 3. And there we go. Okay. So let me talk about a couple more instances or a couple of other examples of when we would use sum and difference formulas here. So let's try these here. Let's take a look at this first problem. So let's write this expression here as a singular function, sine, cosine, or tangent of an angle. Well, if you look at this closely, we've got a cosine times a cosine plus a sine times a sine. And we also see that we're using the same angles, the same two angles. So if you look at this carefully, this is clearly a cosine of A minus B situation here. And I know it's minus B because it's the opposite sign of what I see here. So if my A is 4 pi over 9, and my B is pi over 8, then it's just simply a matter of subtracting these fractions. So we'll write this as 72, that's 32 pi, minus another 72 in the denominator, that's 9 pi. And so this would be a cosine of 23 pi over 72. Okay? All right, let's look at another example here. In this example here, we're told that we're asked to find the value of cosine of u minus v. And you'll see here that we actually aren't given any information about angle u or v, other than the fact that angle u is between pi and 3 pi over 2. In other words, it's in quadrant 3. And angle v is between 0 and pi over 2, so which means that this is in quadrant 1. So let's actually sketch this out. Excuse me. So we know that angle u is in quadrant 3, and that the cosine of angle u is negative 15 over 17. So we can say that angle u is in quadrant 3, and that the cosine of u, adjacent over hypotenuse, is this. So we can use the Pythagorean theorem to figure out our opposite side here, and this is actually a Pythagorean triple. And this would give us 8, but since this is an angle in quadrant 3, we would say that this is negative 8. Okay? Now what about angle v? Angle v is in quadrant 1, and we know that the sine of angle v is 4 over 5. So opposite over hypotenuse. This also is a Pythagorean triple, so our adjacent side here would be 3. So given what we've sketched out, we can actually now find cosine of u minus v, because cosine of u minus v is equal to, using the difference formula for cosine u times cosine v plus sine u sine v. And if we use what we've just sketched out, we can evaluate each of these. Cosine of u, that's given to us, that's negative 15 over 17. Cosine of v is 3 over 5. Sine of angle u, that's negative 15 over 17. And the sine of angle v is also given to us, 4 over 5. So just really quickly to simplify, we've got negative 45 over 85. This is negative 15. Oh, I made a mistake here. Sine of u is negative 8 over 17. I apologize. So this would be negative 32 over 85. So our final answer is negative 77 over 85. And here we go. All right. So hopefully that gives you a good sense of a couple different ways and uses for the sum and difference formulas for sine, cosine, and tangent.